Okay, so good. So this is the interview for the Project B project on Bezier curves. And so I guess the first thing is, what is a Bezier curve? And so the idea is that we've been rendering data sets that have surfaces represented as a series of triangles. And those triangles are, if you're zoomed out, look good, and you see something that looks like a smooth surface. But if you zoom in, you see individual facets. And so as people want to represent geometry in a way that always looks good, then there's a mechanism for constructing surfaces that are analytic surfaces, so they're going to be extremely smooth. And then also a plan for taking those analytic surfaces and then being able to make, either in the case of curves, right here, a series of line segments that represent the curve, or in the case of surfaces, a series of triangles that represent the surface. And what you'd like is to have a property where for a given surface, and in this case we're talking about a specific strategy for doing this, which is Bezier surfaces, that you can tessellate it into triangles in an adaptive way based on the camera position, so it will always look beautiful. Did I say it right? Is
Yeah,
that a good description?
yeah,
Okay.
yeah.
And so for the Project G project, you'll be learning more about Bezier curves and surfaces. And this is actually the second time we've done this video, and so I've looked at it, and the prompt is really good and has a lot of good explanation in it about how the math works and how Bezier curves and surfaces work. And the idea is that you pick so-called control points, and these control points, I want to use the word attractor. Is that an okay word? The control points work as attractors, and they pull the curve
Yeah,
towards the control point.
yeah.
And so then, this is a PDF where my cursor is, but if I were able to click on this red point and drag it, then you'd actually see this curve move towards the control point. And it wouldn't hug up on the control point, because with Bezier curves, they're worried about the transitions from one set of control points to another, and they want that to be smooth. And they actually don't just want it to be smooth like they connect up, but they want it to be smooth in a way that's, what do they call it, C1 continuous. So it means if you take the derivative of the curve,
Yeah,
the derivative is smooth as well.
Yeah.
And so they're doing some extra mathy stuff to make it actually look really good for our eyes. And again, this property of being C1 continuous does it. And so with the project, you've already written some code for them, right? So we have the skeleton code right here.
Yeah.
And this is the right one, right? So we did this once before and we had to make a new version. I hope I have the right one. With this one, yeah, perfect. So you've already written things. So basically the starting point was you took project 1F or 1E and you wrote a Bezier project out of that harness. But then now you've taken out all the stuff that has to do with 1E or 1F, and students will need to put their own stuff in to make this work, right? So here's a color pixel function, and I said, oh, let's not give them solutions to any of 1E and 1F. And so people are going to have to take their own code and put it into certain places in here. But you've also implemented for them line and curve and surface functions, and and I guess you are doing it here. You've made a stub for them here where they have to add the draw functions to do the adaptive refinement,
Yeah.
right?
Yeah.
And they get some number of divisions, and then based on that number of divisions, they build the right number of triangles. So we've got a distracting sound. Now we don't. And so, is there more you'd like to say about the project?
There are three functions that you guys are supposed to implement. The first one does pretty much most of the math stuff of dividing 4 points into, we say, 7.
Where would we find that function?
It's called Bezier divide. I believe there's a...
There's an underscore, yes.
Yes, underscore. So this function will take essentially 4 points. Well, like 4 points as so-called input.
Control points, right?
Yeah, the control points. So the first three parameters we have, px, py, and pz, are the 4 points. All of them are in 3D. And you are going to follow the algorithm that I listed in the instruction to split them.
Is this it?
Yes,
okay.
That's it. And I use the exactly same, Q and R, so that you don't get confused. And you just do the computation and assign those values to the Q and R's. Yeah.
Good.
That's Bezier divide.
Okay.
And the other two is Bezier curve draw and Bezier surface draw.
So here's up in curve, and then the draw function, and here's the draw function and the surface. Uh-oh. We got the phone ringing again.
Okay.
So good. Let's see. Sorry, the phone's a distraction to me. Is there anything more you'd like to say about the project?
I think it's pretty clear in the instruction.
Okay, I think the instruction is very good as well. I mean, you've written quite a nice prompt that has a lot of detail about how Beziers work. There's also a lot of information on the internet, so I think the prompt may be enough. But if it's not, there's a lot more information out there.
Because we're doing a very simple version of the Bezier curve.
Okay.
Yeah.
Very good. And then there's also some input data here in teapot.txt.
Yes.
And so this has control points for the teapot.
Yes.
And then also some images that you'll make, including this is pretty cool that you made this GIF that rotates of a teapot, right?
Yeah.
And so this is what they make with teapot.txt to be able to make images like this. So,
so if they want things to rotate, they will need their Project 1E matrices.
Yeah, very good. Very good. Yeah, so then it would be a matter of doing what they did in 1E to be able to get the cameras to move around like that.
Yes.
Okay, very good. Well, thank you for putting this project together. I know you worked really hard on it. It looks like you did a really nice job. Bezier curves.
Yeah,
Okay.
I like it.
Yeah, very good. I like it too. Thank you, Ha. Appreciate it.